This Week in Virology, the podcast about viruses, the kind that make you sick. From Microbe TV, this is TWiV, This Week in Virology, episode 594, recorded on March 25th, 2020. I'm Vincent Racaniello, and you're listening to the podcast all about viruses. Joining me today from Austin, Texas, Rich Condit.
Hello, Vincent. How are you today? I'm fine.
Well.
That's a noteworthy comment under the circumstances. It is 77 degrees here in Austin and partly cloudy. It's going up to 90 today, unseasonably high temperatures. Yesterday was a record for the date, and that would cause me to, obsess about climate change were it not for the fact that I'm obsessing about coronavirus instead. So every cloud has a silver lining, I suppose. Here we are.
Also joining us from Madison, New Jersey, Brianne Barker.
Hi, it's great to be here. It's 46 degrees here and pretty gray and overcast. I think it's going to rain soon. And I also am fine at the moment.
Could change any moment.
It could.
And from Western Massachusetts, Alan Dove.
Good to be here. It's overcast, cloudy, raw, chilly, sort of 44 degrees Fahrenheit, 7C. Not a nice day to be outside. Not that I would be anyway. But feeling okay.
You like what we do here on TWiV? Consider supporting us financially. Microbe.tv/contribute. Many of you have joined and are helping out. We really appreciate that. I know many of you should get a reward of some kind, and give me a few weeks to get to those. I will. We'll get your T-shirts and mugs and everything out. Let's before we start, this is a special midweek edition, and before we start talking about the situation and answering some questions, what are you guys up to? What's going on in Austin, Rich?
So in Austin, we are now at 98 cases. That's for, I believe, the city of Austin. There have been no deaths. Texas is kind of happily behind the curve to some extent relative to other places in the nation. I was just trying to check. I'm not sure there have been any deaths in Texas so far, but it's got a relatively low caseload. The Austin, as you might know, is a pretty progressive place, and our mayor has put into place a shelter in place. The local government, headed by the mayor, has put in place a shelter in place order until April 13th. I would guess that it would get extended beyond that. And so in practical terms, I mean, as I've said before, in retirement, my life doesn't change a whole lot. But my wife and I are staying very close to home, except for walks and bike rides, and not even going over to my daughter's house, a 5-minute walk away. Maintaining a social distance from everybody. I went on that doesn't mean I can't go on a bike ride or a walk. I went on a bike ride, really nice bike ride with my grandchildren this morning around the neighborhood, and some brilliant soul in the neighborhood posted a thing for the kids suggesting that those who are interested put a one or several teddy bears in their windows. So when the kids go around the neighborhood, they can look for the teddy bears and count them. And cool. Today we found 46 teddy bears.
Nice.
Wow.
It's kind of like looking at license plates on a road trip.
Yes.
Yeah. So, I can feel it getting closer to home as I talk to people. But right now in this moment, we're fine.
Yeah, you have 98 cases in Texas, no deaths. That's right.
98 cases in Austin, I think.
Just Austin?
Yeah.
Travis, Texas. Is that Austin?
Travis County, yes. Okay.
So here, San Antonio has 69, yeah. I don't know how to get it for the whole state. I guess you could go to that other site.
That 1.3 acres site, right?
Yeah.
Is that it? That's a really good site. And if you look at the, it's created by a bunch of first generation or close to that Chinese, okay, in the U.S. And it's incredibly thorough. You can really drill down with this site.
Texas has 1,032 and 13 deaths. That's very good. Great site.
Yeah, and if you open up that Texas thing, it'll go county by county. If you drill down even deeper, you can read about every single case, every single death.
60,000 cases in the U.S.
13 acres or 1.3 acres?
Numeral 1 point, numeral 3 acres, no spaces, .com.
Coronavirus.1.3acres.com.
Yeah, coronavirus.1.3acres.com.
Made with love by first-generation Chinese immigrants. Wonderful. Thank you.
Yeah, it's really great.
So you have 60,000 cases in the U.S., 827 deaths. Brianne, what are you up to?
So I am also sheltering in place as we are supposed to do in New Jersey and not doing anything other than essential travel. Basically, I am teaching my classes over Zoom and otherwise hanging out pretty close to home. And there are actually quite a few cases in New Jersey, not quite as many as New York City, but I think we're the state with the second most cases. So here there's 3,675 cases and 44 deaths in the state. And basically I have made myself a home office and I'm spending a lot of time here, especially working on Zoom and talking to students and advising them how to get through the rest of the semester this way.
How about you, Alan?
Well, let's see. Massachusetts has 1,159 cases, 11 deaths, since we're running those numbers. And I'm just, working from home as I always do. But also not getting out much. I wasn't exactly a get out of the house, go do stuff type of guy, but I really do miss going to the gym. Miss a bunch of other things too. I did make a big trip today. Went to the grocery store.
Cool.
So I think I'm set on groceries for the next couple of weeks probably. And I this past weekend I found 2 N95 masks still in their packages in my basement. I pick these up periodically just for working around dusty stuff. So I sent them with Laura to donate to the hospital where she's working. She got to work on Monday, had a cough, and a little shortness of breath, and so she got sent through the ER as a patient. They gave her a chest x-ray and it was clear, and they said she didn't meet criteria for testing for SARS-CoV-2, so they didn't.
Wow. So,
so she's feeling, she's okay. She was sent back to work, and she's a psychiatrist. She's not, and she hasn't been seeing a whole bunch of patients these days, because she's in her current position. She's really only seeing folks who show up to the ER and appear to need admission to the psych ward, and she's making those calls. But yeah, so she was sent back to work, and that's the way they're doing things in Connecticut, I guess. And she said, well, chest x-ray was clear. I said, good. She said, I didn't meet criteria for testing. I said, good. So we're not quite sure how to feel about that. I mean, yeah, it'd be better if they just tested everybody, but I understand that they can't, so they're prioritizing it. So I don't know. Maybe she was exposed, maybe she wasn't. She's doing okay, and hopefully that stays like that.
I'm sure we'll hear.
Yeah.
Well, I'm at home. I was home Monday. I went in yesterday, so I'm down in the lab as an essential person because there are only 2 people in my lab, me and Amy. So we're both essential. But she's there working. She's doing a coronavirus project. so she can be there. She's actually doing 2 projects, one collaborating with Daniel Griffin with patient samples. And I had to go in yesterday because the nitrogen and 2 CO2 canisters were empty, and she can't do it. Actually, I don't let her do it because they're pretty dangerous to fool with. So I went in and I spent the day there. But I'm planning to be here most of the time. I spend most of the day in my office. I speak with 4, 5, 6 writers a day. Yesterday I did a 2-hour Twitch live stream, did an hour podcast in the morning. This afternoon I'm doing another podcast. I'm teaching. This week Columbia canceled classes Monday, Tuesday, Wednesday because they said not enough faculty were up to Zoom speed yet, which bothered the heck out of me because I'm up to speed, so why should I be penalized? But they said, no, it's not permitted. This comes from the highest levels. I said, okay. I thought we were at a university, not a prison, but fine.
That surprises me. I felt like a lot of us got up to Zoom speed here pretty quickly. We had a lot of workshops, though, right before.
It's not hard. It's not hard. Anyway, I put up my lectures anyway. I recorded one on Monday all by myself. I put it up. They're going to have to look at it. It's going to be on the test. And if anyone says anything, this is a virology course. I'm not cutting out 2 lectures. So that keeps me busy because I'm pretty much revising all my lectures this year. But we're home. My wife is home. My 2 of our 3 kids are home from college. Unfortunately, my daughter is working at Trader Joe's. And so she's there for a number of hours a day. They only let 10 people in at a time, she said. And damn, do they take their time shopping. Those 10 people.
Yeah.
So if I need something, I just tell her. I'm hoping she doesn't bring it home, but we'll see.
Right. I drove by a Trader Joe's, I think over the weekend or so, and I saw how they had people lined up outside 6 feet apart.
Yes.
So they could only let them in 10 at a time.
Okay.
So my younger son was sent home. He came home for spring break, and then they said, we're canceling classes the rest of the semester. And at some point we have to go and get his stuff in the dorm, right? But he's doing online stuff next week as well. So we're all making do. I mean, I hear I'm fortunate. I think we're all fortunate. A lot of people say they're bored. They have nothing to do. We're all pretty lucky. We have plenty to do. Mm-hmm. So
actually, there's a letter coming up. I don't want to be a hard guy here, but I don't have a lot of sympathy with being bored. I have a lot of sympathy. I have a lot of sympathy for people who are living paycheck to paycheck and find themselves out of a job.
Yeah,
and I really feel for those. But bored, dude, we've got lemons here. Let's make lemonade.
Yeah,
and there are a lot worse things than being bored.
Yeah.
Very true.
Right.
I put up a Facebook post yesterday of all of my favorite infectious disease nonfiction books. And I know that a lot of my friends and family have been very excited to read them during their downtime.
Excellent.
I have 2 former students working behind the scenes. I have, some of you may remember Kiki. She was on TWiV. I got her doing a daily literature search for us.
Oh,
cool.
Nice.
She's making a Google Doc. I'm going to share it with all you guys. I said, I want you to search PubMed, bioRxiv, medRxiv every day for COVID-19, SARS-CoV-2, and put the links in and make a 1 or 2 sentence summary. She's into it. She's doing that. I have someone else going through old TWiVs and making little sound bites of us answering questions about on the coronavirus and Ralph Barrick and et cetera. So we'll be putting those up. So cool stuff. I appreciate the help.
Excellent.
All right. We have an update from our friend Jeremy Luban, who's at UMass Worcester, who's been on TWiV a few times. He writes, we had a Zoom call with the coordinator of ICUs in Lombardy. That's in Italy. He said that SARS-CoV-2 testing in Lombardy has been much more selective than it has been in China, focusing only on the sickest people, sending everyone else home to quarantine. The percentage of positive tests in Lombardy is 40%, other parts of Italy 6%. This selective testing could explain the high case fatality ratio in Italy. daughter is a medical student in Bologna. They're in complete lockdown, lectures online for the past 3 weeks or so. You are not permitted to go outside unless to go to the grocery store or pharmacy. Jogging specifically is prohibited all over Italy unless you're in the country.
That's interesting.
Wow. That's one of the things that we are allowed to do here.
Yeah.
Yeah, you can jog around campus.
You can jog around campus. Yeah, absolutely.
Yeah.
Vincent, have you been in the city? I mean, what's the city like? Does it seem different?
So last week I went in all but one day. So just to let people know, I drive in, I park in a garage that's pretty much empty, and walk to a block to the lab, and there are not many people. I never encounter many people, just a bunch of students mostly. It's mainly a residential area up by the medical center, not a lot of stores and so forth. So it is noticeably less crowded. I would say it's about 1% of the foot traffic that you normally see. There's absolutely no traffic driving in or out. I can get in 50 minutes. Normally it takes me an hour and a half. But however, downtown, it's more of a problem. Theodora Hatziano told me the other day that they're at home. She and her husband, Paul Binash, professors at Rockefeller, they're both staying home. And she said they tried to go out for a walk the other day, and there's too many people on the sidewalk, and they couldn't stay a safe distance. So they're not doing that. It's really crowded down there. So
yeah, I had
I
had an email from Stu Schumann, who lives down near Rockefeller, and he made me appreciate that, if you're a New York City resident and all of a sudden, all of the social activities, restaurants, bars, theaters, everything else is closed down. Wow, it becomes a desert.
Yeah.
Yeah.
Now, what they did do in New York City, they released all the homeless people from shelters because they don't want them infecting each other. And so they're living on the subways now.
Oh, wow.
So nobody wants to take the subway.
Are the subways shut down?
No, they're not shut down, no.
Okay.
See,
It's
now
essential.
An ideal arrangement for that would be to use some of these empty hotel rooms that I'm sure the city has got piles of. And but of course, the hotels are not going to go for that.
Well, they did that in San Francisco, right?
Did they?
I'm pretty sure. I'm pretty sure they did
somewhere on the West Coast.
Yeah. So anyway, it's not up to us, right?
No.
The Trump Tower full of homeless.
Perfect.
What an interesting idea.
Mm-hmm.
All right, a couple of stories before we do some email. I noticed now that there's some antibody test kits coming online. These are home test kit type things where, you take a prick of blood you prick your finger, get a drop of blood, and put it on one of those rapid test devices. I have an article here from a company in the UK, and I'm sure there are some that are going to come out shortly here. Of course, there are also laboratory diagnostics to look for antibodies in your serum. Remember, so far we've been diagnosing infection by PCR, but once the infection's over, that will no longer tell you if you have been infected, so you have to look for antibodies.
I really look forward to a time when there are, I hope, huge studies to see what fraction of the population has been infected.
Yes.
Yeah, that would be very interesting.
If that could somehow be done with a time scale, though I don't know how you would do that unless you had archived samples with dates on them. Okay?
Oh, there are plenty of those.
Hospitals and clinics are going to have that.
Yeah, and they can go back to November, October, September, and see how far back people were being infected. I'll bet we'll be surprised.
There's a lot to learn. Actually, my son, who lives in Seattle, right at the original epicenter, he lives in Kirkland with his wife and 3 small boys. Mm-hmm. He said that they, through their family, all of them, had a really, really nasty cold in February. And he's wondering.
Yeah, could be. Mm-hmm. We have a paper it's a medRxiv preprint from a number of different groups. Serological assay to detect SARS-CoV-2 seroconversion in humans. This is if you have a lab and you want to do this. They tell you exactly how to do it, so that's pretty cool. that people are doing that. Okay, so that's good stuff.
It is. So I'm correct that this is all sort of still being worked out? We're not seeing this in any of the hospitals yet, or we're not actually able to get to do these tests ourselves
Not yet.
So that's what we're all waiting for. I know that's what Daniel mentioned last week, that he was really hoping to see, but we're not quite there yet, but we're making good progress towards it.
No, it'll be soon. I'm pretty sure.
Yeah.
A little bit of unsettling news. I have an article here from the New York Times that the president is losing patience with Anthony Fauci, which is not good.
No.
In my opinion, Fauci is an important person in doing the right thing for the health of this country. And the worst thing that could happen would be to fire him. So I hope that does not happen.
I've been thinking about this, and there are so many people with so much trust in Fauci that I can imagine, I don't know if this is possible, but I can imagine that if he got fired, he would essentially go rogue and continue to do what he needs to do without his job.
Maybe advise some governors.
Yeah.
Well, let's hope it doesn't come to that, because he's really terrific in my view, and he's worked for multiple presidents, and he's really important. I trust him very much.
So do I.
Yeah, I do too, and he's doing a great job.
Yeah.
We have a bunch of emails and correspondence about the use of convalescent sera. And Frank, for example, who's a professor at Misericordia University, said, why aren't we using antisera from recovered patients to treat infected people? And we have some email from Ed Niles in a bit, but I want to just say that yesterday the FDA approved this kind of treatment for serious infections on an emergency basis. So if you have a serious or life-threatening infection, you can apply to the FDA for what's called emergency investigational new drug application, and you can get convalescent serum, which means serum from someone who's recovered from the infection. It's checked to make sure there's nothing else, no other viruses in it, and it can be given to you. And we know from previous experience with other infections that this can work.
And the idea here is that someone who has recovered from the disease has antibodies to the virus, in this particular case, the SARS-CoV-2. And so if you give them intravenously this preparation that has these antibodies in it, presumably that can latch onto virus that's infecting you, and those pathogen antibody complexes will be disposed of appropriately in your body. This is what's comes under the general umbrella of passive immunization. So you're giving antibodies from some other source that will last you for some period of time, and it can be up weeks or months, actually. We've been through this before, as opposed to active immunization when you mount your own immunity.
Yeah.
So, Britt, you had some correspondence with Ed Niles. Why don't you?
He's obsessed with this. Let me see here. We haven't highlighted this, but I'll clip through it. This came to me. I forwarded it to everybody. I listened to the first part of TWiV today through the passive transfer comments. Passive transfer being what we were just talking about, passive immunization. It was claimed that passive transfer was first used in Lhasa in 1968. Smallpox docs shouldn't be shortchanged in this regard. VIG, which is Vaccinia immunoglobulin, was used a decade earlier. I went to a meeting in 2009 where several smallpox docs talked about their experiences trying a host of putative anti-pox drugs and the impact on their patients. One had tears recalling the impact of treating sick patients with untested and unproven drugs. I understand the urge to try something, but there are limits. Okay, so Ed, as background, worked for BARDA for a while. I forget what the acronym stands for, but it's a government agency that was born out of the
I think it's
2001.
Biodefense Advanced Research and Development Agency or something like that.
There you go. And he saw a lot of grants having to do with smallpox, anti-pox viral drugs, and et cetera. So he's pretty up on this. And the vaccinia immunoglobulin would be part of that. And he's referring to the 60s and before, when the global smallpox eradication campaign went forward. And one of the things that was used was the vaccinia immunoglobulin. VIG was prepared by two companies under contract with the U.S. government from pooled serum taken from vaccinees, mostly military at this point. We have 100,000 doses in the stockpile. However, 25 doses have been used in some attempts to clear vaccination complications. It provides a link to an article that will provide some background for the practicalities of preparing and using coronavirus immunoglobulin if we get to that. It helped remind me of what we were thinking about 15 years ago. Seems like a lifetime. On another note, pooled monoclonal antibodies have proven to be effective against pox viruses in animal models. Unfortunately, this is an expensive way to go, and suggests contacting our friend Mike Merschlinski for looking in more detail. He attaches an article from an old friend of ours, Rico Wittick, since deceased, published in 2006, that summarizes the prep and use of vaccinia immunoglobulin over the decades. Okay, so this is like a review. He correctly refers to a handful of reported anecdotal applications of vaccinia immunoglobulin against smallpox. I don't know that true controlled studies have been done at this point. By 2011, there were none, even with the compassionate uses of vaccinia immunoglobulin ST246, which was an experimental anti-pox viral drug, now approved, and cidofovir. It was never clear which, if any, of them had a positive effect. You need controlled trials. In each case, the patient cleared and survived. Controlled studies are hard to come by. I'm not a big fan of VIG, vaccinia immunoglobulin. If anyone wants an antibody approach to SARS-CoV-2, they may as well go directly to monoclonals and do the right set of studies. Of course, this will take time. Alternatively, if you have other tools in the toolbox, maybe a convalescent serum study is warranted. Any volunteers? Keep the faith.
Well, that's exactly what the FDA is doing. They're doing a convalescent antibody study in case for prevention. The emergency use is not for prevention. It's for very sick people.
Right.
Okay.
Right.
So Brianne, what could go wrong if you gave someone anti-SARS-CoV-2 antibodies?
Well, if we are imagining that there are no other viruses and nothing else there are some situations where antibodies and antigens can bind together and get sort of stuck in places like in some capillaries, in some areas of the skin, in the kidney, and lead to something that in class I call a type 3 hypersensitivity reaction. But really, it's sort of something called serum sickness, or it's kind of similar to things like farmer's lung that we see in a few different people. So sometimes we can see some issues there where people will make a response to those antibodies that they're getting from other people, because they are technically foreign proteins that you're injecting into someone.
Let's start doing some email here. Brianne, you want to take that first one from Dan?
Sure. Dan writes, "Hello, TWiV. I am a mailman in Minnesota. I had a couple issues with the U.S. Postal Service saying there is no evidence of COVID-19 transmission by mail. First, has there been a study on this, transmission via mail carriers, or are they just saying that because of the life of COVID on paper and cardboard surfaces is relatively short? Second, what about the fact that we touch every single mailbox every day? They are made from plastic or steel, where the surface life of COVID has been shown to be days, and 99% of people are touching those boxes within 12 hours of me delivering to them. These concerns are exacerbated, although it also says exasperated here, and I kind of like exasperated myself. These concerns are exacerbated by the fact that in my station of 40 plus people, we have 2 jugs of sanitizer, but workstations and trucks are not and have not been disinfected once since my time here. We have not been given any cleaning materials or instructions on sanitizing stations or trucks. On top of that, me and 3 others at my station have significant others that are nurses. We are very concerned about being a vector and spreading COVID throughout the city. Thank you, Mailman. Those are some really great points, Mailman. I thank you for what you're doing and for all of the things that you're doing right now. We really appreciate it. And I hope that you do get some more hand sanitizers and better disinfection out there, because I think that your concerns make a lot of sense.
Yeah, this is very well thought out. I am not aware of a real study on transmission via mail carriers. And beyond that, I think that, these are interesting. This is an interesting type of statement. There is no evidence of COVID transmission by mail. Okay. I mean, we use that sort of language all the time. But understanding it's the meaning in depth is appropriate. And I'm not aware of a study. There may be one, but I'm not aware of it.
Now, with that said, I think it's kind of reassuring to look at the modeling that's been done and the degree to which some of the modeling has tracked with the actual epidemic. And the modeling assumptions are based on person-to-person spread, not spreading through mail and package services. If it was spreading through the mail, we would expect to see different patterns than, I think, than what we've seen. And it seems like that's not a major mechanism of transfer, but that's still not getting at the question of, could it be a mechanism of transfer? Could it be a minor mechanism? And of course, for the postal workers themselves who are immersed in the mail all day, the exposure to that is obviously a whole lot higher than me walking to my mailbox and grabbing the mail.
Right.
So I'm not too worried about getting the mail. I think it's probably extremely low risk. But if I were working in the post office and surrounded by all these fomites that people had touched and passing them along, these are legitimate concerns. Please don't stop what you're doing, though. We can't get by without you. My guess would be, that the postal workers and the doctors and the nurses and everybody who's in healthcare are kind of all in a similar boat, and the postal workers are probably at lower risk, but that's just speculation.
Yeah, what you've said about transmission reminds me of Ralph Barrick when we had him on, saying that the epidemiology does indeed say so far that the major route of transmission is direct contact with other individuals, in inhaling respiratory droplets and fomites, that is inanimate objects that might, like the mail, that might carry virus from one place to another, is by a long shot, apparently a secondary route of transmission. But all the concerns are legitimate. I would say also that people talk about this virus persisting on surfaces for days as if there's a drop of virus, it's there for 5 days and then suddenly disappears.
Right.
And you have to understand that it decays over time. And we've done papers before with half-lives. So even though you might be able to detect virus 5 days later, it may be only, a tenth or 100th of what was there originally. And it does decay over time.
And these tests are being done with PCR, which, as we've said, is not detecting live virus. It's detecting viral RNA, and only really spot checking a couple of pieces of the viral RNA at that, which, as I pointed out on Twitter, it's kind of like a dog can smell another dog at the fire hydrant for days. Right. But the smell is not the dog.
Right.
So Until you hear the bark, you don't know that the dog is really there. It's the smell of it. And yes, the smell of the virus, if you will persist on cardboard for 24 hours and plastic for a week and all those figures in that paper under the conditions used in that laboratory study. But is there live virus surviving on that UPS package that's been scraped around an aircraft hold in a truck for the past 24 hours? It seems pretty unlikely.
Right. And I think that we should also point out, if people have heard about some of the recent news about getting virus 17 days later from a surface in that Diamond Princess cruise, that's exactly what Alan is talking about here, that they detected sort of PCR fragments of the virus, not replication competent, virus that's infectious. And so that's a big difference. I know I've had to answer that question for a few people lately.
Right.
Yeah, it's an important point. I like your fire hydrant analogy.
Thank you.
I think despite all this, and I think it's a good discussion, I'd be careful. I'd wear gloves.
Sure.
Since you're contacting a lot of things, for Alan and me, go out to get the mail once a day, not a big deal, but you're touching it all the time. Wear gloves.
Yep.
Don't touch your face. Wash your hands when you get back, and just be aware that there might be virus around and behave accordingly.
And thanks again.
Thank you. Yes.
Yes.
Okay,
Thank you.
Alan, can you take Melissa, please?
Sure. So we're gonna be skimming through most of these from now on, and we will post the entire text of the letters as usual. But we have over 100 pages of email at this point. So Melissa says, in part, I'm a Norwegian master's student here in Norway. We have all of the schools in kindergarten and university shut down for almost 2 weeks now, and it will continue to be shut down for some time. Sweden, on the other hand, have not closed schools, and everything is open as usual. So I guess they go for the herd immunity strategy. We'll see how that goes. And I don't know if that's still the situation in Sweden, but as of this email, I guess it was.
Interesting. We're going to get some interesting data out of all of this.
Yes.
That's what I was thinking too. Yeah. Some countries are distancing, others are not at all. I think this could be really interesting in the end. Someone got a note from Australia that they're still letting people move around freely. So thank you. If you have a report from your country, let us know.
Yeah.
The next one is from Joep, Joep, who, I'm sorry if I didn't say it right.
No, that's correct. I looked it up.
He or she, is that I don't know.
I'm not
Kathy
sure.
would
think I'm not sure.
Anyway, Joep is a general practitioner in The Hague. We work in shifts to spread risk of infection and 2 out of the 11 GPs general practitioners have been sick with corona. 1 tested positive, the other denied testing due to low resources for testing. The daily practice is fairly easygoing with no patients coming in and a lot of reassuring phone calls. We only see high urgent care patients at our practice and therefore not that busy during the day. All patients with COVID symptoms are phone triaged by a GP, if necessary, sent to a specially developed COVID part of the hospital where patients are seen by a GP with BPM and, if necessary, seen by a specialist. What's BPM?
I couldn't
Basic
find
protective measures?
Oh,
Yeah, like
maybe?
PPE.
That's a guess.
I looked it up. I couldn't find anything, but that sounds good. I like that.
That makes sense.
On March 22nd, I did a evening corona shift where I visited the very sick at home. 50%, 3 out of 6, fairly easy shift, were highly suspected for corona. I saw one very ill patient with an oxygenation of 44%,
Ooh.
exclamation point. The man, age 75, had a light cough during a week's time. No fever. His situation deteriorated overnight. Medical history, hypertension, and hypothyroidism. He's currently submitted at the ICU, intubated in a prone position with bilateral pneumonia and treated with chloroquine. His wife, who was not sick, the 22nd, have been admitted to a hospital yesterday. Both are COVID positive. Reason I contact you, besides giving you an insight into our situation, is an article of JAMA, Detection of SARS-CoV-2 in Different Types of Clinical Specimens, that shows low sensitivity for nasal swabs and pharyngeal swabs. Can you explain to me what the contribution is of a test with such low sensitivity? There's a lot of discussion going on here about testing medical staff and the low resources we have. As a GP, I'm not that comfortable with statistics and would be very glad with your interpretations of the article.
I looked through this and I had a hard time sorting it out. Specifically, there were 205 patients that were surveyed, assaying by RT-PCR samples from a number of different sites and tissues. However, the sampling was only on a very few of the 205 for many of the sites. The one that was most common, because I guess it's the recommended, was the pharyngeal swab. And what he's talking about, by the way, Yop is a male name. What he's talking about is the fact that only 32% of the pharyngeal swabs in this cohort of 205 patients were positive. And my problem is that the assumption in the paper is that all of these people were infected, but that was based on a clinical diagnosis. Okay, so I don't know how you can know that they all had SARS-CoV. It could be that what this is telling you is that a clinical diagnosis is only accurate like 30% of the time. So maybe I'm missing something here, but I wasn't convinced that all of the 205 patients were actually infected.
Mm-hmm.
I'd like to see, another study on this. It's worth noting and stuff. I'd like to see more studies. The one other note is that they actually looked for live virus in a few fecal samples and found it. Okay.
Yeah.
Infectious virus. Sorry.
That's clear that we can see it in fecal samples. The question is what percentage, and we don't know that yet. It's something actually we'd like to work on. So Daniel Griffin last week said it's not easy to get a good nasopharyngeal swab, right? Mm-hmm. First of all, you have to put the swab very deep, all the way through the nose into the sinuses. As Ori said to me yesterday, it feels like they're rubbing your brain. He said it's the most uncomfortable thing he's ever had done. And so I think, and I'm looking at these drive-through testers, and they're kind of reaching in the window, and I don't think they're going very high in. And if you don't get a nice swab of the mucosa, you're not going to get a good sample. It's not like taking a mill of blood. You have a mill of blood. You can look for other viruses. But so that's part of the problem. But Daniel seems to have confidence in the test. We can ask him Friday. He's going to come back and talk to us.
If you look at this table, it looks like that the best test was bronchoalveolar lavage fluid, which I would not like to have that done.
No.
That's sticking a tube way down into your lungs and taking a sample, if I understand it correctly, where they got 93% positivity on that. But that was only for 15 patients, okay, out of the 205. And I would guess, I don't know, I'm making this up, that may have been patients who warranted that sort of invasive testing, who may have been more obviously sick. So I think this needs to be done in a different fashion. More patients, et cetera. Okay.
In a BAL, you put a tube in, then you put a little fluid in, right?
Oh yeah. Okay. Lavage. You wash it out,
and then you pull it out. Yeah. Sounds good, right?
Oh, yeah. Jeez.
All right. Ritu writes, I'm a virology student, avid follower of TWiV since 2015. Can you explain this SARS-CoV-2 phylogeny, and provides a link to this site GISAID, which we've talked about before, the genomic epidemiology of the virus, where they post as genome sequences of the virus are published, and they're published very frequently. They have 1,442 genome sequences. They do a phylogenetic analysis, and you can see it here. This is just a wonderful site. You can see each sample, and you hover over it. You can see where it's from, what changes it has compared to everything else, how about percent divergence. And the beauty of this is that you can see as viruses as the virus moves, say, into a new country, it begins to diversify. That always happens. You see a founder virus, which you can identify as coming from somewhere else, and then it diversifies with all these mutations. And that's the value of it, I think, that you can see where the viruses are coming from and where they're going.
Right.
Is that a good explanation?
Yeah. And these are the kind of data that were used in the story that came out of Kirkland some time ago that allowed investigators to look at the virus that was circulating then, compare it to the original virus, and make a speculation as to how long virus might have been circulating in Seattle before the first case showed up. Based on the amount of divergence. I want to also note, however, that this sort of divergence, it's not a huge amount. I don't, in many cases, it's just a few mutations and not necessarily mutations that are of any consequence. Many of them are silent mutations. And I want to emphasize that there is no evidence whatsoever that any of this alters the pathogenicity of the virus.
Right.
Right. So you might expect that if something did affect either the pathogenicity or the transmission, that you would see a big change in the sequence in terms of some sequence would sort of take over and become the dominant sequence that we saw in a particular area. And so we do see some variation in sequences, but there isn't sort of some new variant that has taken over that seems to be better than any others. So it doesn't seem like the virus is mutating in some way to become different in its virulence or different in its transmissibility. It's just mutating the way viruses do.
And I got a request on Twitter from somebody who asked if we could just give a real quick explanation of how these sort of phylogeny and molecular clock analyses are done. So, I mean, real quickly, you look at the mutation rate of a virus or of similar viruses, and you say, okay, we'd expect a certain number of mutations over a certain time period. And then now at this point, a few months out, we actually see the mutation rate of the virus. So we've got pretty good molecular clock based data there. And we can say, all right, it accumulates a mutation every X number of generations in passing in people. So we can project how long this virus has been circulating in people, and we can look at how closely related different strains are and how they've spread, and that's how we can trace back and say, okay, this strain came from, this sequence came from this source most likely, and this sequence came from this source most likely, and this whole thing's been going on since, November or whatever. That's the gist of it.
If you pan down on this, if you look at this site, don't forget to scroll down because there's lots of information under the phylogenetic tree. And I'm sitting here playing this. If there's a world map that is animated, so if you play that, you can see the virus spread worldwide over time, and it highlights on the phylogenetic tree which viruses you're talking about. At the same time, it's fascinating.
Right.
And the tree itself is made by taking all the sequences and doing pairwise comparisons and say which match the best. And then we will put those on the same branches and tips of the tree and so forth. Very cool stuff. Brianne, can you take Emma's?
Sure. Emma writes, I was struck by the percentage of positive tests in New Jersey, 86%, based on the 1.3 acres site. Is this right, or is this some reporting error? And I think that that's a really interesting question. My guess on it is that it is difficult to get a test in New Jersey, and only those people who are tested are on the sick side. And that's why such a high percentage of people are testing positive. And that's both based on my sort of looking at these data, but also on some anecdotal reports I've heard from people who have tried to get tested.
And that varies tremendously by state. I think New York is somewhere around 50% positive. Massachusetts is coming back around 10% positive. I mean, not to brag, but that's most likely because we just haven't had quite as much spread as New York, and so they've been able to keep up with the testing. Connecticut, as I said, as my wife's experience would seem to indicate, it's not terribly easy to get tested there, I guess. So their percentage might be higher. But that is, unfortunately, this is not a figure that's widely reported, but I would like it to be more widely reported because it's kind of an important number to keep track of.
I'm reminded of Jeremy Lubin's letter at the top of the show where he said that the positivity rate in Lombardy is 40%, other parts of Italy 6%. So depends on who's getting tested and why, and et cetera.
And by the way, that is going to have an immense impact on apparent case fatality rates.
Yes.
Mm-hmm.
Because if you're only testing the sickest of the sick, and half the people you test have the virus, you know you're missing a whole lot of cases out there that should be in the denominator. And so you're going to say, oh my gosh, 20% of people with this disease are dying. No, 20% of the people who have it who happen to be sick enough to test, maybe. So they, that number, the percent coming back positive, is an indicator of maybe how much you ought to trust other numbers that are coming out of that place.
Gee, that sounds like the avian H5N1 influenza story of many years ago, doesn't it?
It does.
Where people said, oh, the case fatality is 80%. This is a horrible virus. But no, you're only testing the people who are really sick and come to the hospital. You don't know how many other infections there are out there. I think in the end, we're going to see a much lower case fatality ratio of this virus when we have all the numbers.
Which is not to say that it's going to be small, because we already know from the overload of hospitals that this is substantially worse than, say, a typical flu season. But it's not going to be at the extreme end of some of the numbers that you see from places that are only testing the sickest.
Right.
Alan, can you take Svetlana?
Sure. Svetlana says, I found a podcast on TWiV where you and your colleagues answered someone's question regarding chlorine dioxide gas as a disinfectant against viruses, and it sounded like the first reaction is to assume it's the same thing as chlorine. However, there are two very different chemical formulas. Common household bleach, NaClO, destroys pathogens through chlorination. Chlorine dioxide, ClO2, kills pathogens through the process of oxidation. There's a big difference. Mole for mole, ClO2, chlorine dioxide, is 2.6 times more effective than chlorine. Chlorine dioxide will not react with many organic compounds, and as a result, chlorine dioxide does not produce environmentally dangerous chlorinated organics, and provides a link. And also, here's a scientific study that tests the toxicity levels of chlorine dioxide solution and finds it safe at the highest dose they tested, which is 40 parts per million. Given the current crises the whole world is facing and a lot of testimonies online about using chlorine dioxide solution to treat many viruses and diseases, it would be a very important and potentially life-saving discovery to scientifically show whether or not chlorine dioxide solution can kill this and other viruses in humans, just like it does in drinking water, which is currently approved by the EPA and FDA as well as for processing food. Okay?
So how do you treat something with chlorine dioxide?
I think drinking water, you add it.
So it's not a gas.
I don't know. It may be a gas.
It exists as a gas at any temperature above minus 59.
So it's a gas?
Yeah.
So I guess you could bubble it through the...
Right, you'd bubble it through the water.
Supply, right.
I don't think you could really treat people with it exactly, could you? No.
No,
I
I
don't
think
so,
it
but
would be more to treat surfaces.
Yeah, it's to treat surfaces.
Could you treat face masks with it, for example?
Maybe.
You'll put them in a container and put this in for a certain amount of time, and
maybe.
I think that's being considered, actually. Okay.
So thank you for that.
Oh, by the way, if you're interested in face masks, at our hospital, they're looking at ways to sterilize them because they're running out, right?
Mm-hmm.
And they have found that you can heat them at 56 degrees Celsius for 30 minutes, and that will inactivate viral infectivity. Celsius,
nice.
That's pretty warm.
That's pretty warm.
Yeah.
Yes.
But that's not like oven temperature. That's it's below boiling. It's it's warm.
Boiling.
Yes.
Yeah, it doesn't. I don't know. Does it get 56 in Texas, Rich?
I'm looking it up right now.
No, I doubt it.
I don't think so.
No,
might get into the 40s.
Really hot. Let's see here.
Yeah,
I got my handy dandy. 56 Celsius is 133 Fahrenheit.
Okay.
So
you could put your oven on 133.
It's a warming oven.
Yeah, it's put your oven on low.
Yes. Well,
Okay.
and if anyone is in a lab that is shut down, like all of our labs are, we just donated all of our personal protective equipment to local hospitals.
Mm-hmm.
And so we hope that other schools will do similar things. And so if you have personal protective equipment in a lab and you're not using it in the lab right now because you're home sheltering in place, definitely consider giving it to your local hospital.
Or if you have it in your basement workshop or your shed, as I discovered, I had a couple of masks in mine. Unworn, they want. I actually also had one that's got my sweat stains on it. I did not donate that.
Rich, can you take Julia?
Sure. Julia writes, you asked why South Korea could ramp up testing while others haven't. I work on COVID-19 testing for our state government laboratory in South Australia. As far as I am aware, we have tested the most per capita of any region in the world, 17,000 tests for 1.7 million people. And as an insider in this lab, I can tell you the micro conditions that have allowed this to happen. So what she's saying here is that probably the reason for South Korea handling this, one of the reasons is basically really good pandemic preparedness, as we will see as she goes on. Because it is in-house, the tests that they have in South Australia can be changed very quickly with only probe and primer sequences information needed and a quick quality control process. Tests can be added and removed while maintaining workflow. We use separate liquid handlers, extractors, and cyclers so that if there are problems at any step, we can use other machines or manually fix pipetting. Commercial kits hide raw data. Some of our commercial kit tests used for other purposes in our lab perform all steps on one platform, and a failure at any point aborts the assay. The processes are hidden so that we cannot retrieve any part and have no option but to repeat the assay from the very start. We have grown a system that takes very well-trained people to do the work, but is more flexible at times like these than the commercial platform assays. The political part of our performance, in my view, through my face shield, has been our federal and state governments giving us a lot of money to ramp up what we already perform. So flexibility, I guess the bottom line is flexibility in the process, and being able to do the tests is important.
All right. Thank you, Julia. So we have another one on South Korea from Ariane, who is originally from South Korea and says, I am, quote, just a PhD student in the Netherlands studying viruses. That's what Ori said. I'm just a MD student. Someone said, I'm just a medical student.
Right.
There's no just.
There's always no just.
There's always what you are. From the last episode, 593, I heard you got some questions about why South Korea is dealing with the situation better than others. There's, of course, not just one simple answer. Initially, I wanted to answer that question myself, but then I conveniently found this article on The Guardian that nicely summarized the situation, so I want to share it with you. We have a link for that, microbe.tv/TWiV. Here's the summary. 1, Korean government was ready to mobilize based on the experience with the SARS epidemic. Yes, 2003. 2, Korean CDC and biotech companies reacted fast to develop detection kits, which later allowed up to 20,000 tests per day. 3, immediate testing of asymptomatic people was done from the beginning of the outbreak. And 4, people embraced rather intrusive measures, such as publicly informing citizens of known cases within 100 meters of where they are. Sounds good.
Wow.
Yeah.
And I don't know if it was this letter or another one where it was pointed out that the culture in Korea is
that's the next
conducive.
letter.
Oh, it's the next letter. Okay, fine.
Yeah.
Okay. Brianne, take the next letter.
Sure. Alec writes, one point to remember, though, is that South Korea, like Japan and a couple of other Asian countries, is a homogenous country, even more so than China, which has numerous distinct regional dialects. This may not be politically correct, but it is often a lot easier to push directives like mandatory testing through in a homogenous society than a multicultural one for various reasons. Alec goes on to say, all the foreign workers were quarantined for 2 weeks and not tested and sent home. There were 10,000 Thai workers who were sent home, and some have since tested positive for COVID-19. They were supposed to be quarantined on return, but not all were. And there, Alec is telling us about some of the things that are going on as well in South Korea with their foreign workers. And Alec finally says, just wanted to tell you that I have totally given up on reading Twitter. As I write this, someone just posted something about how you can get the virus from gas pumps, and it was retweeted 3,000 times. Thanks, Alec. I'm so that's unfortunate, Alec. And I think that these are some interesting points about what's going on in South Korea.
And I did not know that they'd shoved out all their foreign workers like that, which is not exactly the best type of thing that I would have liked to see, but I guess that's what they did.
Yeah.
Well, clearly, South Korea tells us that robust testing and fast action to trace and quarantine cases and keep people from moving around has an effect.
Yes.
Mm-hmm.
Sure. And I should say that please just retweet TWiV. I think
yes,
would be better off.
Yes, absolutely.
Because I think more people would learn about it, and a lot of people are enjoying the content.
Yeah.
So please do that. Alan, can you take the next one?
Sure. Scott is basically asking whether a vaccine against this virus will need to induce immunoglobulin A to be effective against respiratory disease. So IgA is in the mucosa, and he's wondering if that's going to be critical. And I think we don't really know the correlates of immunity at this point, do we?
No, not
No.
And then goes on with a report from Tasmania. We now seem to be moving into a period where the government is faltering and losing its grip on the situation. According to the Australian Department of Health website, about 150,000 tests have been conducted so far on our population of 25 million, but up until now, the criteria for testing have been fairly restrictive. We now have community spread happening in most states. I live in the small island state of Tasmania, which has a population of about 500,000 and a healthcare system that is strained at the best of times. We also have a large retiree population and the highest rates of smoking in Australia. There's no evidence of community spread here yet. Despite this, pubs, gyms, and restaurants have all been closed, and some private schools have moved to providing lessons online. Public schools are still open. Our state's tourism-dependent economy has been completely trashed overnight. The way I see it, the next few weeks will be a critical period where we find out if all these measures have been enough. And Scott's a research microbiologist in Tasmania. It's interesting that they closed the businesses but not the public schools. That seems. I mean, yeah, I favor closing businesses too, but I think the schools would really be the place to start.
Yep.
Brienne, can I ask you if
Sure.
So the flu vaccine is injected into your muscle.
It is.
So why does it protect against a infection in the respiratory tract of a virus that doesn't enter the blood at all?
Ooh,
Right.
good.
So it leads to, so the vaccine will lead to the production of antibodies and B cells, and the B cells will be able to go to the area near the lung to protect, because that's where they might see their antigen and they might learn to go back there. And the antibodies will circulate throughout the blood and be able to protect in lots of different sites, whether they are IgA antibodies that may cross into mucosal parts of the lung, or some of the other types of antibodies like IgG that may be in the blood nearby the lung.
So I guess in general, we think that for a virus that invades at a mucosal surface, there has to be some contribution for mucosal IgA, right?
We do think so. I think that when I was in graduate school, this was something that we had a lot of different types of arguments about pretty often, actually, about whether you needed to develop a mucosal vaccine for a mucosal pathogen. or whether something that you were infecting into the blood worked well. And most all of the vaccines we have right now are sort of given systemically. They're not given mucosally, and they seem to work pretty well.
Yeah.
For the new listeners, could we define mucosa?
Sure. Mucosa are parts of the body that are lined with living cells with sort of a wet environment. They're in contact with the outside world. This is things like your respiratory tract, your eyes, your
mouth,
nose, mouth. Yeah, your mouth, nose, your gut. Exactly. And this is a place where we're coming into contact with a lot of different pathogens. And there's this it's basically sort of outside of cells, but as a surface where we can encounter a lot of microbes.
And there's a special type of antibody, IgA, that shows up in the mucosa in an appropriate immune response and helps deal with pathogens at that site of contact. Is that correct?
That is correct. The whole job of IgA is to help protect us at mucosal sites, maybe so that some of those microbes can't get in to the body past those mucosal sites.
Right. And this is, so there's capital I, small g, A. It's immunoglobulin, which is what we call all the antibodies, A. And then there's immunoglobulin G, which is circulating in your blood. And there are some others as well. So those are the ones that we're talking about here.
Yes.
This is not the IgA. This is not the feed store.
No. Yes, there are 5 kinds of antibodies, and I like to tell my students that they can remember them with the mnemonic MDs give everyone apples, because they're IgM, D, G, E, and A.
So I think an example from polio would be instructive here. We have polio viruses, a virus that infects your gut. You ingest fecally contaminated material. The virus goes to your intestines, replicates there. And we have 2 vaccines against polio. We have one that's injected into the muscle, and we have one that you take orally and multiplies in your intestine, then moves into the bloodstream. Both prevent polio, but only the one that you ingest will prevent the virus from multiplying in your intestinal tract because it induces mucosal IgA. Mm-hmm. Right, so there's an example where it makes a difference. Now, we have injected flu vaccines, and we have flu mist, right?
Right.
Which you take intranasally, which presumably does a better job at making mucosal IgA. I just wonder for the SARS-CoV-2 whether we will have some nasal spray vaccines at some point. Probably.
One of the things I remember from a lab that I worked at in the past is that those vaccines are awfully difficult to test in a lot of cases. I know we had a lot of trouble testing some of them in animal tests because the animals would sneeze them back out.
Right.
So this raises the issue again, just briefly, that I was going to comment on earlier. It came up in 2 letters ago, the phrase correlates of protection.
Right.
Which is a really slippery concept because it's really easy to make the assumption that, you make antibodies and that's it. No. And you make antibodies to this particular protein. That's all you got to do. No. Immunity that confers protection can be much more complicated than that.
Everybody with HIV produces antibodies against HIV, and they're great antibodies against the virus. And guess what? You still got HIV.
Right.
Right.
So
exactly.
the antibodies in that case are not a correlate of protection. They're just something your body has done. On the other hand, if you're producing great antibodies against measles virus, you're probably protected. That's a very good correlate of protection.
Right. Mm-hmm. So figuring out what actually protects you in any particular, with any particular pathogen is a critical issue and not straightforward.
There have been a few times where we've mentioned neutralizing antibodies today. Neutralizing is one of the things antibodies can do. That means that they can block viruses from getting into cells or interacting with cells. And so sometimes the correlate is you have to make neutralizing antibodies, not just any old antibodies.
Right.
And by the way, if you find this really interesting and it sounds like immunology is a complex and juicy field, you should check out a podcast called Immune.
You should. Which we're going to record next week, and we're going to answer questions about immunity in SARS-CoV-2. So
Yeah,
if you have any,
good.
send them to immune@microbe.tv.
Maybe I'll send you my questions about hyperinflammation.
Why don't you just join us, Brianne?
That's fine with me too.
Yeah, you should join us. I'll let you know the schedule.
Okay,
Since
that'd
I don't
be great.
think, aside from teaching, you probably have some time, right?
I do.
What did I want to say? Oh, so there are two other things you can do. So this week, one of my lectures is on adaptive immunity. We talk all about neutralizing antibodies, et cetera. No, it's the wrong place. Virology.blog/course. Virology.blog/course. And you can find Brianne's immunology lectures online too. Where would people find those?
So mine you can find on YouTube, or they can find on my website, bbarkerdrew.com.
bbarkerdrew.com.
Mm-hmm.
Okay. Rich Condit, can you take Bob's?
All right. Bob writes, is there something questionable about chloroquine phosphate now that someone has died? And cites an article that many people may have seen about a man and his wife ingesting fish tank cleaner because the ingredients listed chloroquine phosphate, which has been has been discussed in the media as a possible coronavirus treatment. And he died, and his wife became critical and has since recovered. And wow, what can I say?
Yeah.
Chloroquine, there are different things you can do with chloroquine, and it can be formulated in different ways. And chloroquine phosphate is probably a fine fish tank cleaner, and methanol is a fine substance to have around, but don't take chloroquine phosphate as a drug, thinking that it's the same as the drug form of chloroquine, and don't drink methanol as your shot in the evening, thinking that it's the same as ethanol. These things matter.
Yeah, it's unfortunate that...
there's also no good evidence that hydroxychloroquine, which is the drug that people have been talking about, is actually going to treat SARS-CoV-2. And we had Daniel Griffin on talking about that and the difficulties of that paper. But at least that is a drug that's designed to be taken as such. So just because you see the familiar a similar word on the label, that does not mean that something's chemically equivalent.
Unfortunately, someone made a proclamation that chloroquine would be good, and as a consequence, many people listened, and you shouldn't medicate yourself. You should go to a doctor. Go to a doctor.
There are lots of crazy home remedies showing up on social media and elsewhere. Just go away. Stay away from that stuff. You can...
Mm-hmm. And if possible, we need to do some more studies on hydroxychloroquine. It's being used for a number of different medical conditions, like some autoimmune diseases like lupus right now. And some patients are starting to have trouble getting it because so many people are trying to get a hold of hydroxychloroquine to protect themselves against COVID-19. And so we should try to protect all of the people who have other conditions as well and need that medication.
Conditions for which it is actually tested and effective.
Right.
Yes.
It will be tested for treatment of COVID-19. If you go to clinicaltrials.gov, there are many ongoing trials of hydroxychloroquine for other applications, but you need to know how much to use for virus, et cetera. So those
and
will
you
be
need
done
to know
if
that
it
you're
works.
not causing more harm than you're treating, because this is a drug with side effects.
All right, Michael writes another article about how South Korea handled the outbreak so well. He links to an article in Korean, but it's translated here. Here's my partial translation of a Korean news article titled, Korea 220,000 versus Japan 8,000. What was the secret behind the coronavirus testing as of March 10th? And now this begins the translation. South Korea averaged 17,000 tests a day. The death rate is lowest among countries, about 0.7%, higher than seasonal flu, which is 0.1%, but smaller than MERS at 30% and SARS at 10%. Some key points here. The preparation for new infectious disease after MERS became a stepping stone for biotech firms. I think previously we heard that SARS-1 was also an impetus for creating programs to be prepared the next time.
I don't know if you saw, there was an article by Ed Yong in The Atlantic about COVID, and he said that scientists were calling SARS-1 SARS Classic.
Yes.
Yeah. Yep.
I think I did
I've
that
heard
on
that
a previous episode. Yes.
Yeah, we did it before Ed Yong. Yeah. Ed Yong doesn't listen. Two hospitals across the country are equipped with experts and equipment, providing excellent infrastructure. SARS-2 information exchange highway provided by software companies with advanced IT technology. So those are some of the things. The full text is available.
They were prepared and had competent leadership is
Yep.
the short version of this.
Yep.
Yeah.
That's the magic formula.
Could you take the next one, Daniel?
Sure. Daniel writes, kind of surreal how things have changed since I was walking to the bus stop listening to TWiV 582 at the beginning of the semester. Yes, Daniel, I would think that's an understatement.
Yes.
My mom sent me this analysis today as a forward from a friend of hers who claims to have received it from his friend who is a physician and
Physicist.
a physicist, and in quotes, specializes in data collection, analysis, and interpretation, end quotes. So every scientist ever. And Daniel says, I would be curious to hear your impressions of this document. So this is a document that talks about what's going on in Germany.
Basically, it claims that the whole thing is due to testing and that the virus was there the whole time and it's no big deal and we're only seeing it because we're testing for it.
Absurd. Completely absurd.
Yeah.
Yeah.
I think that perhaps this person should take a look at what's happening in some of our healthcare centers right now. I'm pretty sure that that's a real phenomenon happening that our healthcare workers are working on.
Some IT person data mined obituaries from Italy, which was interesting, and showed the spike in obituaries that is just completely out of proportion to what had gone before. And so people are dying at surprising rates.
This is not... People are not dying because we're testing for it. That's a crazy idea. This was originally detected in Wuhan because there was this huge number of people with atypical pneumonia above the background. And now we're seeing more and more of it. So Daniel asks, is this acting irresponsibly to distribute this? Yes.
Yes.
The person is not thinking clearly.
Beware of people, I'm sorry, but I'm going to pick on physicists because this seems to afflict their field at a higher rate than some other field, who go blathering on about stuff that they were not trained in ever and seem to think that because they're an expert in one thing, they must be experts in everything and should therefore inflict that expertise on the wider world. No, this is just a fundamental misunderstanding of epidemiology and virology and immunology. And unfortunately, if somebody says, oh, wow, he's a physicist, he must be smart. No, that just means that he probably has a good grasp of physics and should stick to it.
And beware of anything where you can't really identify the credentials of the individual, detail who wrote it, and that clearly has not been peer reviewed. That is an article that hasn't been examined by other scientists to see if it's legitimate. Is a great argument for peer review. You just got to be really careful about what you read and apply critical thinking.
I want to just point out, though, last episode we discussed an article by John Ioannidis, an epidemiologist from Stanford, who published an article in Stat.
Yes.
Saying we're overreacting because we don't even know how many infections there are. And this is also irresponsible because people dying is not an overreaction, right?
No.
It's just crazy to think that we're overreacting when we see what's happening, the number of deaths, et cetera. And if we have more infections, we're going to have more deaths. So I don't know why a certain number of people have to have this contrarian view when it's clearly wrong. I can see a contrarian view when you have a good point. But in this case, we can see what's going on here. So don't do it. Alan, can you take Nina?
Sure. Nina is a returning listener who has started a company to identify the correlates of COVID-19 protection. Says one of the perks of being home inside more has been to pick up TWiV, as I was an avid listener in graduate school while doing tedious repetitive experiments lonely in the lab, and you even read out one of my letters back then. Woo! I really appreciate your work and information broadcast on the topic. I wanted to share a link to the official announcement of my company called Adaptive Biotechnologies. We're working open source on understanding the immune response to COVID, and gives the link. Adaptive will open enrollment in April to collect de-identified blood samples using a LabCorp-enabled mobile phlebotomy service from individuals diagnosed with or recovering from COVID-19 in a virtual clinical trial managed by Covance.
Sounds good.
Check that out.
Very, very nice.
Great.
Rich, can you take the next?
Ryan writes, are you concerned that acetaminophen might attenuate the patient's fever due to the detriment of the immune response? When a patient has a requisite physicality, why not let the fever rip, especially in an early COVID-19 case when the lungs aren't compromised, subject to monitoring and observation, of course. We discover more about the immune system every year, but the picture looks pretty clear that it is adapted to do particularly well in hyperthermic temperatures. For example, here's a Nature Review immunology paper from 2015 that covers a variety of mechanisms whereby a fever appears to be immune protective. Yes, Daniel does need to buy a bigger boat. He's talking about Daniel Griffin, as do the rest of you. Okay, so what's the role of fever? Should we let it run its course?
Well, I'm no doctor, but when my kids have fevers, we don't let it rip because you can get really screwed up. And if you have a high fever, you can go into shock.
Right.
So
I think part of it is a question of what level of fever you're talking about.
Yeah.
Right.
I mean, physicians always try and manage fever, right? So we should ask Daniel on Friday.
Yes.
But what do others think about this?
I have a hard time responding to this because I'd like to hear a doctor's perspective on this. Okay, I understand the logic of the argument, and the logic seems compelling, but I'd prefer a clinical opinion on this.
See, here's the problem. So say someone has 101 fever. Oh, we'll let it rip. What if it goes up to 103 then?
Right.
You can't predict that. So you want to manage it before it gets out of control.
And it also,
Brianne, Brianne, what is the role of fever in an immune response?
So there are a lot of studies. This review talks about some of them where immune cells are able to function really well in a higher temperature. And they also are able to move around the body better. There are changes in the integrins that help immune cells move around the body so they can get to infected locations a little bit better at high temperature. And there are also some metabolic changes that happen at that high temperature. So there are a bunch of reasons why fever could be positive for the immune system. But again, there's sort of the low fever of, 100 and the high fever of 103. And I'm not sure we should lump them all together.
Right. Mm. And it also matters a lot whether we're talking about an adult or a kid.
Yep. Because
fevers that an internist would say, "Oh my God, you've got to medicate this." A pediatrician will say, "No big deal." Because if you're 4 years old and spiking a fever of 102, it's less of a big deal, apparently. But again, none of us are MDs, and when Daniel's on, probably on Friday, maybe we can run past him. Should you take NSAIDs when you spike a fever?
Right. And either way, stay home with that fever.
Stay home with that fever. And personally, I mean, I'm going to take some aspirin because it's I'm weak.
Our next one is from Melissa, who relates the story of a sibling who back in February had some unknown illness, fever, chills, coughing, and some digestive issues, which now the writer says, having listened to the last episode, sounds like it could have been COVID-19 all the way back then. But flu tests were negative, never got a SARS-CoV-2 test because there weren't any in the state at the time. And so she basically is saying you should, if someone has these symptoms, to try and get them tested.
Yeah.
Well, it also speaks to the notion of the idea, and only time will tell, that this virus was circulating pretty widely in the U.S. before we really took notice.
Yes, I think that's very likely to be the case.
Yeah, Brianne, can you take the next one?
Sure. Kit writes, so Kit has actually been listening to a recent episode 593, and Kit wonders, might SARS-CoV-2 be damaged by a kitchen microwave? And Kit is thinking about maybe looking at masks and I guess putting them in a microwave to get rid of the virus, and says there's some precedent from the CDC who talks about the microwaves that are produced by a home microwave oven and their ability to inactivate bacterial cultures, mycobacteria, and viruses. And so Kit would like to know, we'd love to fund a study to find this out, but I have no idea where to start. Do you have any advice on who to contact, etc.?
So I understand that people at NIH are looking at this. They want to figure out how to sterilize personal protective equipment for obvious reasons, because we're running out of it. And so I think these studies are underway. I'm not sure. You have to be careful with a microwave because you can set things on fire.
Yes.
Especially the face mask type material. So don't try this at home. I don't know who to contact if they want to fund a study on this.
I would say, so I assume Kit means wants to get funding for a study, or if Kit is somebody with money looking to fund a study on this, then maybe they could clarify. And but I think the NIH would be the place to approach about funding. Actually, in either case,
send an email to Tony Fauci.
That's right. I'm sure he's got time to answer.
Yeah.
Right. I'm sure he doesn't have too many emails right now.
No.
Well, he has assistants. Someone told me they emailed him last week about something. They asked him why he touches his face at the press conferences, and so apparently his assistant answered and said, "Yeah, that wasn't a good thing to do." Anyway, so
mainly because he was putting his palm against his face and bowing his head down. Yeah.
Alan, can you take the next one?
Jean-Francois writes, basically, what do we think of the flu trends in CDC data, and are they linked to social distancing? Talking about influenza trends and looking at the weekly influenza surveillance report from the CDC. And so I think the thing to bear in mind here is influenza is a seasonal disease. We do know that about it. We do not know that about SARS-CoV-2, but it should be on the way down now, and I think it is.
Yeah, I
looked at
the
quite
surveillance report, and it doesn't look to me significantly different than what we ordinarily see.
Yeah.
Yes.
This looks pretty normal.
Yeah, it started going down week 7. Is that right? 2020, week 6 or 7, yeah. And beginning of the year, January, and it's gone down ever since. So I don't think we can see any effect of social distancing on that. But we did have that report out of Hong Kong, which suggested it did, right?
And the seasonality is different in Hong Kong. Also, their implementation of social distancing was earlier, but the seasonality is different there because it's a tropical climate. So they're in the wet season, dry season pattern. And maybe in that case, they would not be expecting to see a decline, and they did. That would be the key question.
So I did a presentation to Google employees a couple of weeks ago, and it was fun. I was talking about viruses in general and SARS-CoV-2 specifically, and I was amazed to see Sergey Brin was in the audience. How cool is that?
Wow.
Because I could tell, because when people leave a conference, it was a Zoom, I think.
Mm-hmm.
And it goes, Sergey Brin has left the meeting.
You can find us on Patreon.
You can. That's right. Rich, can you take the next one?
So this is from Neil, who's an architect and wants to know about how hospital architecture might help infection control and whether this experience we're having is likely to change things. He says, at the moment, I would love to know more about the use of mechanical, plumbing, and security systems for infection control in medical facilities. This might be second nature to clinicians, but it's always nice to talk about the basics, especially as we build improvised hospitals. I'm curious if anyone is thinking through the application of what we learned from this pandemic. And what this letter made me think about is our tour of the BSL-4 facilities. Okay.
Yes.
Now, granted, that's a high-end situation, but although I don't know in detail, I can imagine that a tremendous amount of thought is put into mechanical, plumbing, and security systems as are relevant to infection control in hospitals. Because infection control is a huge deal in hospitals, and I think it's on the top of everybody's mind. However, I would also imagine that we will learn from this pandemic, and perhaps that will impact on future designs. Sure.
I would put an asterisk on that. I hope that newly constructed medical facilities are built by people who think through the infection control issues. I don't think this is second nature to clinicians. I don't think they give second thought to where the plumbing goes, nor should they. But a lot of hospitals are established buildings that were put up in 1933 or whenever, and everything is retrofitted and everything is expensive to retrofit, and the decisions that are made, infection control is a consideration, but it is subservient to so many other considerations when you're trying to route the Ethernet cable through a building that pre-existed modern electrical wiring, that I think a lot of this stuff is probably not done the way it would ideally be done, and I don't know that there's a solution to that. But this is a really interesting subject, and I would encourage Neil to continue seeking out other architects who maybe work in that field and see what they have to say. And if there are other architects out there listening to this, let us know, what's done when you design a hospital. How do you incorporate infection control and what's in that field?
Yeah, I was thinking there must be architects who specialize in hospitals, healthcare facilities, because there are architects today who specialize in building in indoor farms, right?
Right.
Mm-hmm.
Sure.
So
Sure.
there must be.
And research
whenever
laboratories.
Whenever I go to a hospital, and I'm sitting in a room, I look around and I say, this is a cleaning nightmare. There are nooks and crannies everywhere. It should be built in a way that you could close the door and it could clean itself, like those bathrooms they had in New York City for a while, the outdoor toilets.
Yes.
You would close the door and the whole thing would be scrubbed down because it's one smooth thing of stainless steel. Something like that would make a lot of sense.
I mean,
or
they
at
certainly
least to
do
put
things like have no carpets,
Well, right.
Yeah.
which makes it easier
Usually
to clean.
there's no carpets. And the other thing is to put copper on certain surfaces that are used a lot, and that would inactivate, because Michael Schmidt has done studies that show if you put copper onto bed rails, you would reduce hospital acquired infections. So yeah, it's a cool area. Who read that? Is that Alan? That's Alan.
No.
That may have been me.
I think that was
Yeah, that was me.
Okay, so that means me. This is from Ellen, who wants to know, she and her boyfriend were in Colorado in early January, and they got a unusual cough that lasted a long time. It was flu negative. I wonder if it could have been coronavirus. Sure, absolutely. January, I think it's very possible. This virus was circulating in November in China, and, travel is very, very easy between the countries. So this is where we might be able to do some retrospective serology and figure that out. We'll see, but I think it's very possible that you were infected back then. Brienne, can you take Felix?
Sure. Felix writes and has some questions about vaccines and immunity. He says, "Hi, I like your podcast, but I haven't learned your names. So hi all. I have two different questions. First, he has a question about kinds of vaccines. What ways do we currently have of making vaccines? What are the differences between them? Which of these are being considered explored for the campaign against COVID-19? And two, immunity. How does immunity ultimately work? Why is it that some vaccines have an expiration date on the immune system, like tuberculosis? Does immunity wind down as time passes? Is ultimate immunity impossible, or is it possible to be vaccinated and otherwise healthy and still get the measles? Does it depend on the disease itself? Cheers." I guess I had more than two questions, huh? Oh, and stay safe. Thank you for making your podcast even during this pandemic. It's much appreciated and much needed. Thank you so much. And that's from Felix.
So, Felix, you got about 400 hours? Yeah.
I was gonna say, how much time have you got for me here?
But great
We've
question.
talked about some of these issues before in other podcasts, right?
And these are the core issues in vaccinology. I gather, Felix, that your background is not in this, and you have just absolutely nailed, I think, most of the central questions in vaccine development and immunology just in this one short email. So this is awesome.
Can we do
I would
this, or
love
do
to
we
sit
need
down and have a really long conversation with you about immunology, Felix.
Can we do this, or do we need a vaccines 101?
I think we may need a vaccines 101, but we can take a quick stab at some of the, maybe just kind of give the dimensions of these problems. So what ways do we currently have in making vaccines? There are two main types. We've got, at least for viruses, we have the killed vaccines and the live vaccines, and the killed vaccines are inactivated virus that's given to you, and your immune system recognizes the virus bodies and then can recognize them again when you get reinfected. And then the live vaccines are ones that go in, and it's a weakened form of the virus that goes and actually replicates and starts to grow, but it can't make you sick. And then your immune system sees it and mounts an immune response, and then you're immune to that virus.
And I would add two more vaccines to that. One is subunit vaccines, where you give just a component of the vaccine, like of the pathogen, like a protein or something. And another is what an old friend of mine would have called punk vaccines. Okay. And these are various high-tech sort of approaches, like a virus vector that's not the pathogen that infects you, but is by recombinant DNA technology expressing a component of the target pathogen, or more recently, just injecting nucleic acids, RNA or DNA, that encode the appropriate immunogen.
Right.
Good. Okay.
So,
Brianne, how does immunity ultimately work?
Well,
2 minutes, right?
Yeah, right. So there are different types of immunity. I think the one most people think about when they are asking this question is something called adaptive immunity. So you have some cells in your immune system that are specific to a particular virus, actually specific to a little piece of that virus. And those cells are able to recognize that virus the first time they see it. And they will divide a whole bunch and make more copies of themselves. So there are more soldiers to fight that virus, as well as getting better at the ability to protect. And those cells will live for a really long time. Sometimes that immunity does wind down. The number of cells that you got, the number of your soldiers you have to protect, will sort of decrease over time. And it does seem like that varies a little bit, depending on which microbe we're talking about. Some of them it lasts for a really, really, really long time. Some of them it doesn't last quite as long. So there is a lot of variation there.
And Felix asks what approaches for vaccines are being considered against COVID-19, and I would say all of the above.
Yes.
The one that made the press recently that is a phase 1 clinical trial where there's a small number of people that they're looking for safety and as a secondary efficacy in terms of whether or not the people make antibodies is in the punk category, I would say. And that is a messenger RNA that encodes the spike protein of the coronavirus. That is the protein that decorates the outside of the virus and is required for attachment. And they inject the messenger RNA, and that gets into cells and causes the spike protein to be made, and you hopefully mount an immune response to that. And it is known that antibodies to that spike protein will neutralize the virus. Whether that is ultimately the primary correlate of protection or not, I don't know.
But we do have some clues from other coronaviruses that the antibodies against the spike protein are likely a good candidate for protection. So that's a good place to start.
Yeah.
Well, these are all going to be rolling out over the next year. We'll talk about them.
Yeah.
Stay tuned. Stay tuned, Felix.
I'm really, personally, just me, probably others too, but personally, I'm really excited about this mRNA vaccine. I really hope it works. It's interesting. It's really interesting.
It is really interesting.
All right. Alan, can you take Betsy?
Yes. Betsy wants to know, why isn't takeout food a high concern for spread?
Spread of what?
Well,
just kidding. Yes.
You can get a nice
refer
spread.
To the mailman, refer to the mailman conversation at the top of the show. I mean, it's where you can't have zero risk. Okay.
Right.
Mm-hmm.
So yeah, it's a concern. It is not as much of a concern as many other things.
I would say the cooking of the food is going to inactivate any virus that would be in it. The one concern might be the outside of the container,
Mm-hmm.
which,
Right.
when we get it, we wipe them down, take the food out, throw out the container. The real issue are those vegetables that you don't cook, like lettuce, right? How much of a risk is that? So I asked Vincent Munster at NIH, whose lab did some of those infectivity studies on various surfaces, and he said that they're not looking at that. But if you are worried, you could soak the lettuce in a dilute bleach solution and then soak it again in a dilute soap solution.
Yum.
The bleach, and then soak it in water. To which I would say, forget the lettuce for now.
Yeah.
And I would say, as a general note, just a food safety note, I try to avoid uncooked vegetables in restaurants. I've tried to do this for years. And when I buy them in the supermarket, I try and get ones that I can easily wash. Uncooked fruits and vegetables are a huge source of foodborne illness. So setting aside coronavirus concerns, I do not want norovirus in the middle of this. I don't want, any of the stuff you can get from foodborne infections. And whatever you do, please don't eat sprouts.
No.
Sprouts are a problem. The problem is, Alan, if you go to a market, all those heads of lettuce are out there, right? And people are touching them, and you can imagine they would, even the ones in packages, they were packaged somewhere.
They were packaged somewhere, yes.
Yes. So at least with your takeout, I think that what Vincent said about, taking the food out of the takeout container, getting rid of the takeout container, washing your hands after you touch the takeout container is sort of the best you can do. Zero risk. You're not going to find a situation where there's zero risk, but this is something that you can probably do safely.
And you have to eat, and I don't think this is any riskier than groceries.
Right.
Mm-hmm.
Rich, can you take the next one?
So Gary is writing about ACE inhibitors, which we've covered before. And just to summarize, ACE2 is the the receptor for the virus on cells. And he notes that production of ACE2 receptors may be upregulated in response to ACE inhibitors or receptor blockers that are included in drugs that people take for some conditions, and wonders whether that might exacerbate infection. We've covered this before on several times. So Gary, thanks for writing. We're going to refer you back to previous episodes.
Yep.
Yeah, there's no evidence that there's any effect of these. I think that it's an interesting hypothesis, but no information there.
It is, and if you're on ACE inhibitors, that's probably because your doctor prescribed them, and you should continue taking what your doctor prescribes until your doctor tells you to stop taking what they prescribed.
Exactly.
Yes. Yeah, good point.
You're on those drugs for a reason.
Yeah.
Shweta writes, Shweta's in Rotterdam, PhD candidate at the Erasmus Medical Center. I thought it would be nice for you guys to discuss in your podcast, how could PhD students or people who are at home handle this situation, which is that Shweta is now missing the lab and the stress is getting to her. So how do we deal with this? Any tips, reaffirmations I could use to prevent being lab sick will be appreciated.
I've been thinking about this letter ever since I read it yesterday. And I would say this is a glorious opportunity to expand your horizons. Okay. Could take it from a retired guy. You can easily fill up your time with all sorts of just wonderful stuff out there. I appreciate the fact that you love the laboratory, and that's great, but you can't go there now, so suck it up and take this as an opportunity to, like I said, expand your horizons. Exercise, read, cook. If you like the lab, take up cooking, work in the garden, write. If you're really addicted to science, this is a great opportunity to dig up all of the literature that's ever been written on your field and go back. I would, if it were me and I were going to do that. I love going back to the historical roots of my discipline. I think really important, and I've only discovered this late in life, is exercise. Get out.
Yes.
Okay.
Yeah.
And if you can't get out, then exercise at home. And the weather here has been crummy, and my daughter and I have been doing like burpees and exercises that you can do just in the house if you have to. But yeah, those are all great suggestions. And if you're into video games and you want one that's got a kind of an academic theme, I highly recommend Fire Emblem Three Houses.
Awesome. I see that you have this comment about improving your informatics skills, and that's something that I've thought about as well. But otherwise, I would say if you really want to do things related to the lab, I second what Rich says about reading a lot. And one of the things that I have really come to notice recently is, I've been posting things on Facebook and thinking about sort of science communication with a different audience than I usually do. In terms of friends and family who are really non-scientists. And I've been really surprised at how impressed they are and how much they say, oh my gosh, I'm so excited that, I finally am getting to hear more about what you're doing. And I was like, don't you know that there's a lot of ways to hear about it? But anyway, I almost wonder if, this might be a time where you could think about something like blogging or some other way to write about the things that you would be doing in the lab, so that different people can read about them. Because I've been really excited about how many people have been commenting to me lately, how much they have enjoyed when they've been home reading and learning some of the background of some of the science they've been hearing about in other places.
For those of us who are not seriously economically impacted by this, and that's our good fortune. Others are not so fortunate. To me, this is the silver lining in this cloud is that this is a real opportunity to explore other aspects of existence. So go for it. Take it.
All right. All good advice. One more. Let's do one more. Brianne.
All right. Anonymous writes, From what we're hearing, it seems like there has been a shift in the virulence of the disease, and that China, Washington State, and California have experienced the disease targeting more older and compromised people. But Italy and places like New York are seeing a much scarier, more severe disease that is targeting younger and older people. And Anonymous wants to know what we think about those effects. My guess, Anonymous, is that this probably has to do with which people are being tested, and which people are sort of making their way into health centers. And I don't know that until we have kind of those serological studies or bigger picture testing of a lot of people, if we're going to fully be able to say if there's something happening in different groups. And I think that infection of older people or infection of younger people, both is in fact rather scary. So I don't know if one's scarier than the other.
Are there actually any
evidence,
data that says that?
No.
I didn't think so.
No, there's
There
no
are
change in
anecdotal,
virulence.
yeah. So there are reports that are getting huge amounts of forwarding online. This healthy 25-year-old got coronavirus and got exceedingly sick, and yeah, I mean that's happening. Nobody's at zero risk. But in terms of the numbers, I think you're looking at a lot of testing artifacts. But the data that we have that are solid enough to maybe draw conclusions would suggest that nothing has changed, that this is still the same level of risk for different age groups that was seen in China.
So I yesterday looked at the data from the Italian outbreak, stratified by age and percent deaths. It's exactly the same as the numbers from China.
Okay.
No different.
Right.
Very young people, no deaths. In Italy, no deaths under like 29 years of age.
Wow.
And then as you go up, a few more, and then the oldest, the most, and that's exactly what it was in China. So there's no increase in virulence, no change in virulence. It's just a perception issue. And as Alan said, you have one case in a 30-year-old somewhere, and then it gets all blown out. Oh my gosh, it's now targeting young people.
Right.
No.
And you said there are no deaths in people under 29. That doesn't mean people aren't getting sick and people aren't having a lot of symptoms.
There's a wide territory between I'm fine and I'm dead. And you don't want to you don't want to explore most of it, really.
Right.
The Princess Bride comes to mind, you know?
Yeah.
All dead. There's mostly dead.
Yes.
All right. On that note, we will wrap up this midweek TWiV. You will find the show notes at microbe.tv/TWiV. If you listen on a podcast player, please subscribe so we know how many people are listening. If you have questions or comments, TWiV at microbe.tv. And if you want to support us in our efforts to spread the good word about viruses and nowadays about corona, SARS-CoV-2, microbe.tv/contribute. Can give as little as $1 a month on Patreon or PayPal. Joining me today from Drew University, Brianne Barker, who's on Twitter as BioProf Barker. Thanks, Brianne.
Thanks. This is great to do. It was nice to be back.
Alan Dove's at turbidplaque.com. On Twitter, he is Alan Dove. Thank you, Alan.
Thank you. It's always a pleasure.
Rich Condit is an emeritus professor, University of Florida, Gainesville, currently residing in Austin, Texas. Thank you, Rich.
Sure thing. Always a good time. And thanks, Vincent, for the opportunity to do something positive. This is great.
Yes, thank you,
I'm
Vincent.
Thank you. You're welcome. You're welcome. I'm Vincent Racaniello. You can find me at virology.blog. I'd like to thank ASV and ASM for their support of TWiV and Ronald Jenkins for the music. This episode of TWiV was recorded, edited, and posted by me, Vincent Racaniello. You've been listening to This Week in Virology. Thanks for joining us. We'll be back in a few days. Another TWiV is viral.